Hello, Articos here to share with you integration. So integration is the process of anti-differentiating. So anti-differentiating is just a reverse of differentiation. So in here we focus on our function y equals to r of x. So before we differentiating these functions, we'll say we're going to drive y with respect to x. Since the function depends on x, we'll get r prime of x. So now is to go back from r prime of x back to r of x. So what do? We integrate. So that's called integration. So we represent it usually this way. The integral of r prime of x dx is given by r of x plus c, where in this case, this sign, it indicates the integral sign. So here, this r prime of x as the derivative of r of x is called the integrand. And this c is the constant integration. So r of x is just the antiderivative of r prime of x. So we have two types of integrals. We have indefinite integral and definite integral. We can let r prime of x to be f of x, and we can let r of x to be big F of x. So, which means that the derivative of the big F of x will get a small f of x. So, in this case, this one represents indefinite integral. So, for the definite integral, it has to do with boundaries a and b. These are the boundaries for this function. So, it is an area that is between a and b for this particular function. So, graphical representation, it can be written as this one. So, we have from a to b. So, we shade this part. This is what we're talking about. So, which means the value that we're going to get here for this area is the same as integrating from a to b of f of x to x. So that's a definite integral. But we'll talk about that, you'll understand what. So right now, let's just focus on basic laws. So under basic laws, we have a constant law. Remember, basically, when we're differentiating any constant times x, we're going to get the constant. So now, going back, when we integrate the constant, we get constant times x. So that's how we do x. So that's how it is. So constant multiple law, whenever we're integrating a constant times the function, we can always take a constant out to integrate the function. So the sum and difference. So this one indicates that we can split our integral sign through addition and subtraction. So the power rule. This it was derived from power rule of differentiation. So power rule of integration is the same as this. So we have the exponential and logarithmic laws. You remember what happened. So this is what is basically happening, and also, so for you to understand this, can I kindly do this activity in here? Suppose you are to integrate 3 into 1 minus 1 over x plus 1 over x squared minus cos 4x plus sin 5x minus e to the power 3x plus 5 to the power x, close bracket dx. So this, if you can look carefully, we can treat this part as the function itself, the whole thing, as f of x, and we can treat this 3 as the constant. That's why it's in the form kf of x dx, and by the constant multiple law, we're allowed to take the constant out. That's why I say this is the same as I can take 3 out then and integrate this part. So since these are just how many times are in this function? Following this function is 1, 2, 3, 4, 5, 6, 7. So I can split it through this law of sum and difference. So that's why I was able to split, and each and every time it has its own integral. So as you can see. So proceeding further, the integration of a constant is a constant times x, as you can see. The integration of 1 over x is just the absolute value of x, as you can see here. So, and also another thing that you have to realize in here, you can see how did I write 1 over x squared. I wrote it as x to the power negative 2. So, and remember, the integration of x to the power n is given by x to the power n plus 1 over n plus 1. So in this case now our n is negative 2. That's why I wrote negative 2 plus 1 over negative 2 plus 1. So for the integration of cos of 4x, when we integrate cos, we get of kx, we're going to get 1 over k sine of kx. So that's why I wrote 1 over 4 sine of 4x. And also the integration of sine of kx is 1 over k, is negative 1 over k cos of kx. That's why in here you are having negative 1 over 5 cos of 5x. So, and also the integration of, as you can check here, the integration of e to the power 3x is the same as the integration of e to the power kx. We can write it as 1 over k e to the power kx. So in that case, our k is 3. So that's why I wrote 1 over 3 e to the power 3x. So lastly, the integration of a to the power x can be written as a to the power x over ln a. That's why I wrote 5x over ln 5. So it's a matter of simplifying here. This is what I get. So, method of simplifying, this is what I get. So after simplifying, this will be my final result. So what I did here, I just basically applied the laws to integrate what I was given. So this is in a simple format. You just have to apply the laws. So for you, you just have to understand these laws. So you just have to put them in practice. Don't claim them. So hopefully I did make it better for you to understand what's going on with integration. And you all will come. Thank you.